Hello everyone. Today we're going to be talking about EPNS, what problem EPNS is solving, and by the end of the video we're going to be doing some demos showing you how you can integrate EPNS into your protocol, into your hackathon project, or into your service. So as of today, there is no way for protocols to reach out to users through their wallet address. We rely on Twitter or Discord or Telegram to notify users about something that has happened. And if we think about it, that's not how we are used to do in our day-to-day life. For example, if I'm waiting for a very important email, I know that I'll get a notification whenever I receive this email. I don't need to keep constantly going to my email provider and refreshing the page, seeing if I have a new email. I'm going to get alerted whenever there is a new email. Or whenever I'm expecting any deposits into my bank account, I don't need to go to my bank account and keep constantly monitoring or checking the balance on my account. I know that I'm going to receive a notification whenever someone has made a deposit. So for the user experience perspective, is much better. The users get notified about information they care, and they can focus on doing other things instead of constantly checking about a particular information. On Web3, we still don't have something like this. And what will be the notifications, for example, in Web3 space? It can be, for example, a governance proposal. Whenever there is a new proposal, it would be nice for users to get notified in their wallet addresses, instead of the users having to constantly be checking Discord or Twitter about a new proposal. This definitely would increase community engagements and participation into proposals. For DeFi, it would be nice for users to receive notifications before they are liquidated. This definitely would save a lot of users' funds, and for a user experience as well, it's a better experience for the user in general to actually get notified whenever they're about to lose their funds. For ENS, for example, in the UNS case, it would be nice for users to receive a notification 7 days before they're about to lose their ENS domain. And just to reiterate, the notifications, they can be both based on-chain events, but they also can be based on off-chain events. For example, if you have a newsletter and you want to send a newsletter to your user's wallet address, you can totally do this. On the demo, we're going to show you guys how to do this, but just to reiterate, the notifications don't need to be necessarily on-chain events, but they can be also based on off-chain events. And in this case, on the newsletter, you're going to be sending a notification to the users about your newsletter to your user's wallet address. And once the user clicks on the notification, the user is going to get redirected to your newsletter page. So the solution that EPNS is building, we're building an open communication layer. So we're working on nodes that community will eventually be able to run the nodes, and they're going to get incentivized by running them. And any community member will be able to run the nodes. And any community member or any person can query those nodes and fetch the information and actually verify the notifications have not been tampered with. The notifications, they are dynamic. So what you send the notification is completely up to the protocol to decide. The notifications, they can be a video, they can be an image, they can be pretty much anything. There is no limitation in what the notifications can be, and most importantly, there is no limitations on how you're going to notify your users. If you want to notify your users based on on-chain events, you can, or off-chain events, you can. How often you're going to notify your users, there is also no problem. It's all up to the protocol to decide how they want to interact with their users. The solution is also multi-chain. Even though our name is Ethereum Push Notification Service, it's because we started on Ethereum, but we're going to be across all EVM chains and also non-EVM chains. Sending notifications and receiving notifications, they're gasless. So if you want to receive a notification, all you have to do is to sign a message to show that you are interested in receiving notifications for that particular channel. For example, in the Aave channel, you can just sign a message saying, okay, I want to receive notifications for the Aave channel for my liquidation alerts. You have, as an end user, you pay nothing. And also sending notifications. If you send notifications on the dApp or using the SDKs, they're completely gasless. Only the on-chain notifications. If you want to send notifications using your smart contract, you have to pay gas. But besides that, everything's gasless. And it's platform agnostic delivery. You can receive notifications anywhere. For example, we provide like a mobile application, we have our own dApp, we have a browser extension. You're completely free to see the notifications there. But we also, and we encourage protocols to use, we have SDKs. So we definitely encourage protocols to use our SDKs to receive notifications right on your dApp, for example. The users never need to leave your dApp to receive notifications. Or more importantly, the users never need to leave your dApp to opt in to receive the notifications. All of this is covered on our a demo that we're gonna do on the SDK. So long story short, the user never needs to leave your dApp to opt in to receive notifications, and also never need to leave your dApp to receive the notifications. We also recently announced something called SNS module for push delivery nodes. So this allows you to add logic in a way like to the notifications. So for example, our push delivery nodes, they're gonna be calling one of your webhooks whenever there is a new notification, and based on the notification, you can react. For example, you can build a Telegram bot, you can build a WhatsApp bot, you can build pretty much anything. You can display your own push notifications into your mobile application. If you already have a mobile application, you can just react to the events that the push delivery nodes are gonna call your API. You take this notification, and you can send push notifications to your already existing mobile application if you want. This is called SNS module for push delivery nodes, and we have a very extensive documentation for all of those ways of receiving notifications into docs.epns.io/developers. So as I said before, there are multiple ways, and how you're gonna notify your users is up to the protocol. So for example, I give an example for DAOs whenever there is a new proposal, liquidation alerts whenever there is a new farming, so users can start providing liquidity into the liquidity pools. NFTs, for example, whenever someone places a bid into your NFT, it would be nice to get alerted by this event. Or if you're part of, you're playing a gaming, you get notified into your wallet address whenever there is a new community event, so you can participate into your gaming community. Those are some, we call them friends of ETHSanFrancisco. So those are the protocols that definitely helped us to shape the notifications and make the protocol completely agnostic and, most importantly, flexible on how we notify the users and what we notify the users. So yeah, so you can definitely see each use case for those we call friends of ETHSanFrancisco into our blog. So for each protocol, we provide an article explaining how they are using the notifications to engage with the community or to notify users. So definitely head over to the ETHSanFrancisco blog to reach out on how they are using notifications into their protocols. We're very active in hackathons, so we always have hackathon bounties. We have a push grants program. We have $1 million if you're building a protocol project and you want to get funded to keep working to this protocol into your project. Please feel free to apply for a grants program. It's completely open and transparent, so anyone can see and participate into the push grants program. So a little bit how the protocol works under the hood. So first of all, we have on the left here, we have the ETHSanFrancisco core contract. So the ETHSanFrancisco contract, it resides on Ethereum, and it's responsible for the channel creation, for governance, channel state changes, and as well as all the incentives mechanism. And just to make sure this contract here, it lives on Ethereum. We have the ETHSanFrancisco communication contracts, and those contracts, they're completely multi-chain. They live on EVM chains and also non-EVM chains. And those are the contracts whenever you want to send a non-chain notification, wherever your smart contract is deployed, you're going to be calling the ETHSanFrancisco communicator contract deployed on that specific chain that your smart contract is deployed. Here in the middle, we have the push nodes. So the push nodes, they are responsible for validating all the notifications, the events. They do validation, they see if the notification is actually correct, is following the standard, and if it is, the push delivery nodes, they're gonna dispatch the notifications to the end users, so the end users are gonna receive the notifications tied to their wallet addresses. So that's pretty much it. Those are the socials that you can reach out to us. We're gonna be doing some demos now and showing you guys how you can integrate into EPNS into your own protocol.
And now let's do some demos. First of all, we'll see how to create a channel on Push Protocol, previously EPNS. We'll learn how to send notifications manually using the DApp, smart contract, the SDK in your backend, or using a scaffold solution called Showrunners. We'll also see how to customize notifications with content markdown, images, and videos. We'll finish by doing a demo on how to integrate notifications into your own DApp, and also we'll be receiving notifications for Web 2.5 platforms.
And now let's create a channel on EPNS. One analogy that I like to make is think about a YouTube channel. So whenever you created a channel, users, they can subscribe to your channel and they are gonna get notified whenever you upload a new video. EPNS channels work the same way. You're gonna create a channel and users, they can opt into your channel to receive notifications. So to create a channel on the testnet, you go to staging.epns.io. You click here on the left menu here on create channel. So I already, on my wallet here, I already have ETH and I claim the free DAI here. But if you need DAI or ETH, just click on these buttons and you're gonna be redirected to the corresponding faucet. So yeah, I already have 50 DAI, so just click on next. Yeah, let's create a channel name. So it's gonna be demo tutorial, creating demo tutorial channel. Channel description is gonna be creating a channel. Channel website URL, that's the URL about your protocol or about your website. So in our case, we can do youtube.com. Let's click on next. So we need to upload an image. So I have an image here set. So I'm going to upload this sword here. Let's crop the image and let's create the channel. So we're going to need to do 2 transactions. The first transaction is to approve the DAI. And the second transaction is to create the channel. Once the channel is created, I'm just gonna copy the address here. I'm gonna go to my other browser, and what I'm going to do, I'm going to simulating another user here, opting to my channel, to the channel that I just created to receive the notifications. So I'm gonna here on the search, I'm gonna search for the newly created channel, which is this one. I'm going to opt in to receive the notifications. So all I have to do is to sign a message. So opt-in and opt-out to receive notifications, they are completely gasless. So no transactions fees involved. So since here the browser on the right has already opt-in to receive notifications to the channel that I created, so all I have to do now is to send the notifications. So I come here, I click on send notifications here on the left. There are 3 types of notifications. So I can send broadcast notification, which means I'm gonna send a notification to all subscribers to my channel. I can send a targeted notification, which means that I'm going to send notification to a particular wallet address that is subscribed to my channel. Or I can send a subset notification, which is I can send notification to an array of wallet addresses. In this case, I'm just going to send a broadcast notifications. I'm going to create a title here, is hello there. Notification message can be hi. Yeah, we have here in the bottom a preview of notification, so let's send notification. So just have to sign a message. Send notification is also gasless. Just sign a message and the notification has been sent. So if I come here on the right, click on the inbox, the notification should be here as it is. And also on this browser here, I have installed the ETHSanFrancisco browser extension. So if I come here, I see also the notification here.
Now let's see how you can send notifications from your smart contract with Push Protocol. First, head over to Push for Hackers repo. Go to Send Notifications folder. On this folder, there are multiple examples on different ways on how you can send notifications. You can send notifications using the SDKs, the subgraphs. You can send manual notifications. You can send notifications using our scaffold solution called Showrunners. And in this case, for this demo, we're going to be sending notifications using smart contracts. So let's go over this folder. Let's go for this demo. Copy the content of this token modifier contract. So let's copy the content of this contract and let's explain what this contract is doing. So I'm going to call this contract push.sol. Let me copy here. So what this contract is doing is we're importing the ERC20 token contract from OpenZeppelin. We're defining the interface here for the communicator contract, which is the contract we're going to be calling, and we're going to be calling the send notification function to actually send the notifications. We're defining here the push contract. The push contract is an ERC20 token, which has a constructor, and upon deployment, we're going to be minting 1000 tokens to the deployer of this contract. We have here a public address that we call ETHSCOM address. This address is going to depend on the chain your contract is deployed. For this demo, we're going to be deploying our contract into Coven. So let's get the corresponding address, the correct address for the communicator contract in Coven. So let's go to push.org documentation, docs.push.org. We have the communicator address deployed on multiple chains, but in our case, we are interested in the Coven chain. So let's go over here and let's copy this contract address here. Let me paste it here. So I have the correct address here. The push contract, we are overriding the transfer function from the ERC20. And what this function is doing is we're calling the internal transfer function here. And after the transfer is done, we're going to be calling the communicator contract, the send notification function here. First, we're going to be sending notification from this contract address here, which I have selected here. So for this, let's get the correct address for the channel that we have previously created. So I have a channel here that I have already created. So let's copy the channel address. Let's head over to the contract and let's change this address here with the correct address from our contract. The 2 is the recipient of the notification, and here is the notification itself. If you go over to docs.push.org, we go over for each property here and we explain how you can prepare and set your notification payload. I just want to point out on this example, we are sending a target notification. And the notification content, notification body is going to have this content here. But please, for more information, go to docs.push.org. Here below, there are just 2 helper functions that we have created just to prepare the notification, so the notification appears good for the recipient. Let's compile our contract. So I'll press Command S. The contract was successfully compiled. So now let's deploy the contract. I have selected here injected provider MetaMask. We're indeed on the Covo network. Let me select the correct contract. In this case, the push.sol contract. Let's deploy the contract. Let me confirm the transaction. The contract was successfully deployed. So let's get the contract address. So the contract address was deployed on this address here. So after contract deployment, we just need one more step, which is head over to your channel that you're going to be sending notifications from. Click Add Delegate. Now you're going to set as delegate the contract that you have just deployed. Click on Add Delegate. Just confirm the transaction. We have successfully added a new delegate. So before sending the notification, let me opt in to receive the notifications. So we're going to be sending the notification to this wallet here, but this wallet's not opting to the channel, so let's opt in to the channel. So first, let me copy the contract address, which is here. Let's head over to the other browser. Let me search here for this contract. Let me opt in to receive notifications from this hello channel. Sign a message. I have successfully opted into the channel. Perfect. So let me copy this contract at this wallet address here. Let's go back to Remix. Let's expand our deployed contract and let's call the transfer function, which is this function here. So let's expand here. So let's send to this address here, the address that I just opted into the channel. Let's send 500 tokens. Let's click on transact and let's confirm. The transaction has just been approved. So just as a refresh, we call this function. We're going to be transferring the tokens, and after the transfer is successful, we're going to be sending the notifications. So let's go back to the other browser. Let's click on inbox, and you should see the notification here, as we can see. So the notification has been successfully sent from the smart contract to the end user.
Now let's see how we can send notifications using the Showrunners. Showrunners is a scaffold solution that allows developers to quickly start send notifications using EPNS. To get started, just go to docs.epns.io on the How to Set Up Showrunners section. First of all you need to do is to clone the repository. Let's head into the folder, install the required dependencies. Once the dependencies are installed, let's open the project. So as we can see here in the documentation, after we need to copy the .env.sample file, rename it to .env, and do some changes on this. So let's do this. So I'm going to create here a .env file. I'm going to copy all the content from here, and I'm going to paste here. So we're going to do sending notifications on the testnet environment, so we can keep this variable as it is. For log level, let's add debug. In Fura project ID and in Fura project setting, secrets is not needed now, so we can just set as no. And the same thing for the advanced configurations. As of now, we're not gonna need to use them, so we will just set them to no. Once you do this, you open the source folder and the Showrunners folder here. As you see, as of now, the Showrunners folder is empty. Note that there is also a folder called sample_showrunners. Once you open, you see a lot of boilerplate code start running and sending your notifications. For example, we have here an example on how to send notifications for Aave, how to send notifications for ENS domains. We have here a Hello World boilerplate code and proof of humanity. In our case, we're gonna be running the Hello World. So all we have to do is take the Hello World folder, drag and drop here on the Showrunners folder. Move yes. So it is here. Once you do this, all you have the last change that I have to do here, you go to this hello world keys.json file, and you edit here the information related to the channel that you have created. In this case, we are sending notifications on the testnet environment. So I have here that's the wallet that I have created a channel on the stage environment. So this wallet, I already have created a channel on the previous demo. So the first thing that I need is the private key of this wallet. So all I have to do here is come here, account details, export private key. Let me write my MetaMask password. Once it's done, I just copy the private key and I'm going to paste here. I'm gonna paste it here and also here. For the chain ID, since we are sending notifications on the testnet environment on the Kovan network, so we're gonna add here, we just leave EAP 155:42. And that's pretty much all you need. So let's go head over to the terminal to start running this. So first of all, we need to start running Docker. So we do Docker compose up. Once Docker has run, you open a new terminal and you're going to type npm start. Once you do this, you see the Showrunners framework now is starting. So let's start sending our first notification. So here on the Hello World folder, we see a Hello World routes file. So what we are going to do, we're going to be sending a post request to this endpoint so we can start sending the notifications. So for this, in my case, I have Postman open here. So how to set up this URL? So we know here that the port, the server is listening on the port 5432, which is this port here. And after we just append this, so the /APIs is on the loaders file. If you go here to the loaders, express, here, config API prefix, that's the /APIs that you see here. And the showrunners /hello world, you can find it here, showrunners /hello world /test notifications. And this is a post request, and this is what we have here. So all we have to do now is to send the request. As we can see, we got success, 211. That means the notification has been sent. So to test this, I'm going to open this new old browser here. So this is a wallet address that I already have opting to the channel that I have just sent a notification. And which channel did I send the notification from? Was from the channel that I set the private key here. So all I have to do here is go to the inbox. Let me refresh. And here is the notification that I've just sent. Demo tutorial channel, hello world. Now let's see how to send customizable notifications on ETHSANFrancisco. Once your channel is created, you click on Send Notifications tab on the left menu and you're gonna get redirected to this page. On this particular demo, we're gonna be sending a broadcast notification, which means a notification to all subscribers to your channel. We're gonna be adding a custom title to the notification, and the title is gonna be My New Pet. For the notification message, we're gonna be sending a customizable notification, which means we're gonna be adding this message here, here's my dog, on bold, as we can see here. For a full list for all the support notification content, head over to docs.epns.io on the notification content section, and we have here a full list of all the supported types, as well as examples of how to use them. We're going to also be adding a media to the notification, and we're going to be sending this image, which is my new dog. We're also going to be adding a call to action link. This link is whenever the user clicks on your notifications, they're going to get redirected to this link here. Once the notification is set, we just click on send notification. All we have to do is sign a message, and the notification was sent. So now, here on the browser on the right, I have a user that has already opted into my channel. So once the user head over to the inbox section, we're gonna see the notification here. You see the notification has a blue border, which means it has a call to action link. Once I click on the notification, I'm redirected into this case, to a YouTube video. On this demo, we're gonna see how you can use the ETHSANFrancisco SDK into your DApp. We're gonna be fetching all the notifications from a particular wallet address, and also we're gonna be creating a button on the screen so users can opt into your channel so they can start receiving notifications. So first of all, head over to docs.epns.io/developers. Go to the ETHSANFrancisco SDK section here on the left. On this page, we have added this table here, and on this table, we have all the features that the SDK provides, the description for each feature, and the corresponding package that you're gonna need to import to do this. And also we added here the target platform if this feature can be used on the UI, or if the feature can be used on the server. For example, you can use the SDK to send notifications. We can use the SDK to opt in and opt out to notifications. And this is what we're going to be doing in this demo. We have the notification component. We're going to be using this to display the notifications in a beautiful way in the UI. And I have other elements here, so you can take a look. Let's go over to fetching user channels details. That's what we're going to be doing today. So here it displays how we can fetch the notifications from a particular user. So note that we are calling the getFeeds API from the ETHSANFrancisco SDK. The user section, the user property here, all we're adding is the user wallet address, as we see here, and we add this prefix before the wallet address, which means that we're on the Ethereum chain. The chain ID is 42, which means that we're on the Coven testnet. So we're fetching all the notifications from this wallet address on Coven testnet. And the environment is staging because that's the testnet. I have created a sample code here so we can go over it together. So the sample code is going to be provided in the description, so you guys can take a look at your own time. So what I'm doing here, let's go over here to this return section here. What we're doing here, we're just iterating over all the notifications, and we are passing the notifications to these notification components. So first of all, let's take a look of what is these notifications here. They're just an array. And this array is set right here. So all I did is add it here on the under user effect. So whenever the application starts, I'm going to be calling this notification function here. And all it's doing, I'm calling the same getFeeds API as we saw in the documentation. So what I did, I copied this, I pasted here. The recipient address, I just added the address here, one of my address that I have already opting to a particular channel. The environment staging, and I just limited myself to 5 notifications so I can display beautifully on the UI. So once I set notifications here, the notifications are set here once the application starts. If we scroll down, we see we're then passing all the notifications fetched from the SDK and passing to this notifications component. Let's go over inside this component. For this component here, I took this code here from the documentation itself. So on the documentation, there is a link to the GitHub with a lot of examples on how you can display beautifully the notifications on the UI. So also this GitHub repo is also going to be the links below. It's just one way that I did to display the notifications in a very beautiful way. So you, as a developer, don't need to spend time formatting the notifications, but just fetching the notifications themselves. But all the links to this code here are going to be provided, and also examples on other React components that you can add to your application. So we're here, what we're doing, we just take notifications, iterating over them, and displaying on this notification item. And look, notification item here is a component that I just imported from the SDK UI web. So let's start the application. So the application has already started. Let's come here and here. So we're just iterating over the 5 notifications, and we are passing the notifications to the notification item component here. And this notification item is a component on this library here. So once I pass them to this component, well, the notifications, they're all formatted on the screen. Right, and you see the notifications, they have a blue border, which means they have call to action links, which means that once you click on the notification, the user is redirected to the call to action link that you set it. Let's take a look now on how the users can opt into your channel. Of course, users can go to the EPNS tab and opt into your channel in the EPNS tab, but it's way better for user experience perspective. So for users to opt in to receive notifications right on your DApp itself. So users don't need to go to DPNS to opt in to start receiving notifications. So in this example here, just to recap, the users can start receiving notifications right on your DApp. And also we're gonna see how users can opt in to receive those notifications on your DApp. Let me just comment out this and then comment this. For this, all I'm doing, I'm just following the steps on this section here in the documentation. We have a section here called opt-in and opt-out. Once click here, all I'm doing, I'm just following the steps here, right? So all I'm doing, I copy this function here, And this function, all it's doing, going to opt in to a channel that I have previously created. So I copy this code here, and I pasted this code here. I created a function called opt-in channel that I just copy and paste and change the signer here to the signer that is connected into the browser. So I just hard-coded here a channel address that I have created. The signer is the user currently logged into the browser. I get the user address, and I call this function. So let's see how it works. Let's go to the DApp, see the button here. Once I click it, there's a message that pops up. Now if I sign this message, then I'll start receiving notifications from your channel. So users don't need to leave your DApp to start receiving notifications. They can see notifications on your DApp, and now they can also opt in to receive notifications right on your DApp. On this demo, we're going to be using the EPNS SDK to send notifications and also to receive notifications. So for this, we need to import the EPNS SDK and the ETHJS library. We're going to need the private key of the wallet that created the channel on the EPNS DApp. In this case, I added the private key on the .env file. You're also going to need the channel address. And you see the channel address, it's following the KEP10 format. So you just add EIP 155 column chain ID, which in this case is 42, column the channel address. In this demo, we're going to be sending a notification to this wallet address here. So I just pasted here as the recipient address variable. To send notifications, it's straightforward. All you have to do is call the send notification function. We're going to pass the notification information and most importantly, the notification payload. The notification is going to have a title, a body, and in this example, a call to action. So whenever the user clicks on the notification, the user is going to get redirected to this URL, in this case, a YouTube video. Once the notification is sent, we're going to just console a message. And here in the bottom, we have a get notifications functions. And in this case here, it's just to display how you can fetch notifications from a particular wallet address. In this case, you just call the get feeds function. You pass the wallet address following the KEP10 format here. You pass the environment. Since we are sending a notification on the staging environment, you just pass staging here. And here, I'm just passing those limit and paid to fetch the latest notification sent. And here on the bottom, we're just calling those two functions above. To run this, just node index.ts. So we can see the notification has been sent. And this is the notification that was fetched by the push storage node. So to see the notifications, there are multiple ways where you can see the notifications. You can see the notifications on the EPNS tab, mobile application, browser extension. You can integrate with the SNS module and receive the notifications directly from the push delivery nodes into your webhooks. On this example here, I'm going to show you how to receive notifications on the browser extension. So you see here, the notifications, it has this blue border here that once I click it, I am redirected to the video, to the call to action. We're now going to do a demo on SNS module for push delivery nodes. It allows very easily to integrate push notifications to your platform of choice, whether it's a wallet, browser extension, Telegram, Twitter, Discord, or any app. Push delivery nodes are a decentralized solution to enable Web3 to Web2 bridging. They allow any platform to receive communication from push storage nodes. The push storage nodes, they are responsible for validating and indexing all communication and tying them to your wallet address. The SNS module is a mid-level solution that eliminates all the heavy load of running a node or syncing information and gives you webhooks that you implement to start receiving notifications, chats, or any other Web3 communication in your software. It works by writing all the user's Web3 wallet communication into Amazon SNS as a topic. You, as a developer, only need to subscribe to the topic to start receiving those notifications. This eliminates the majority of infra building on the developer side when they are trying to create a POC out or ensure instant integration to Web3 notifications. So I've got here a demo, and on this demo, we're going to be doing a Telegram bot, right? So since we get the notifications from push delivery nodes, what we do with those communications, we can do anything we want. In our particular case, we're building a Telegram bot. So just before going over the code, all the code here, I'm going to provide the links by the end, so you guys can dive deep into the code. And also I'm going to provide the link for the documentation with further explanation. So here we just import everything, all the imports necessary to run the Telegram bot. And here is the webhook that we are creating. So whenever there is a new communication on the push delivery node, the SNS is going to be calling this webhook. And what this webhook is doing, all it's doing is taking the data, parsing the data. We're validating the payload received by SNS. If the payload is of type notification, in our particular case, since we are building a Telegram bot, we're just gonna take the payload and we're gonna be sending the notification to the Telegram API. So here, that's the EPNS DApp. So I already have created a channel, right? So now I'm gonna send a broadcast notification to all the subscribers of my channel. So I'm gonna send them a message, hello world. The notification message is gonna be SNS demo. Okay, here we have the preview of the notification. We're gonna now send the notification. All I have to do is sign the message. It's completely gasless to send the notifications. The notifications have been sent. So if we come here back to the Telegram bot, we see indeed that we received the notification. And if we come here to the Telegram, we have received the notification here. You see, we're also receiving a lot of other notifications here, but the notification that we are interested in is this SNS demo here. Yeah, those are the links. I'm also going to provide you guys a link to our article that we posted. Here there is information about further explaining what the SNS module is, what the push delivery nodes are, what is the push start nodes, so on and so forth. So you guys can dive deeper into this. There is also the GitHub repo. Here it's going to be on the links as well, and also the links for our documentation.